Hey guys, we have an optics ka question, right? Question is based on prism. So the question says that there is a prism made of glass of unknown refractive index. So uh, remember 1.5 is something that is most of the time given in the question, but for this question we have an unknown refractive index of the glass. So mu g. So let me write down the data as I'm reading along. So mu g is unknown, right? And then there is a parallel beam of light on one of the faces of the prism. Angle of minimum deviation is so del min, minimum deviation angle is 40 degrees as per the question. And this is when the prism is kept in air, right? What is the refractive index of the material of the prism? That's the question. The refracting angle of the prism is 60 degrees. So they are telling about the angle of prism, that's 60 degrees right here, right? And the refracting angle, if the prism is placed in water, it essentially shows a new angle of prism. So that's something that we have to figure out. So these are the things that we have to figure out. So we can do that, but the general tendency of the students is to use this particular formula, and that is del min is equals to mu 1, which essentially means reflective index of 2 with respect to 1, minus 1 into a. Now this is a valid formula, but when I went through the derivation, I had said repeatedly, I repeated it multiple times, that this is only when the angles are really small. Look at the angles that are given in the question, right? We have something like 40 degrees, we have 60 degrees. These are not small angles. Small angles generally mean something that is lesser than 10 degrees. So this value is, this formula is correct, but this is not applicable here. This is not applicable, right? This is not applicable here because the angles are too large. So we have to go from the basics, right? So I'm gonna have to use the basic derivatory formulas that we came across. Now if you go through the derivation of prism, and I'm gonna do it one more time just to make sure you remember this. Like if this is a, okay, and if you have like an incident ray coming in, if you have an incident ray coming in, and let's say this is angle I, it refracts first and then it refracts again. So let's say this is the emerging angle, so you have something like r1 and this is r2, and the angle of deviation is somewhere in the middle. Now, if you remember correctly, the few conditions for a minimum deviation is that first is I should be equals to E. Once I becomes equals to E, it implies key R1 becomes equals to R2, right? So from using these two conditions and one general condition which says key delta is equals to um, I plus E minus A, we figured out, and this is in case of minimum deviation, you get something like 2 times of I minus A, and from here the angle of incidence came out to be A plus minimum deviation by 2, and R came out to be A by 2, right? Now if the angles were small, the ratio was directly taken in terms of the angles, as in when you write the Snell's law for this one, let's say this is n1 and this is n2, then n1 into sine I, now I in this case is A plus del min by 2, became equal to n2 into sine of uh, A by 2, right? This was the general relationship, and from here we took that assumption that these angles are really small, and we just ignored the sign. We just wrote n1 into A plus del min. Now this is where you have to make the change and essentially work with a scenario where you are not assuming that. So you will simply say n1 into sine of, now angle of prism is given to us, that's 60 degrees I believe, right? And minimum deviation is 40 degrees, so 60 plus 40 divided by 2 is equals to n2. Now this is glass. N1 in our case is air, like the first scenario is when you have air and glass here. So air ka n1 I have taken just 1, ng into sine of 60 by 2, sine of 60 by 2, right? Now when you solve this, now you're gonna get something like sine 50 is equals to ng into sine 30. Now there's no way you will know sine 50, okay? So you're gonna have to put it in a calculator and then figure out, let me get one more, let me move this thing up a little bit. Yeah, let's move this away here. right? So you have something like, oops, something like the refractive index of glass being equal to sine 50 divided by sine 30. Okay. Now this approximately, if you plug it in the calculator, I think this comes around 1.5. It comes out around 1.53, right? So this is how you do this particular question, right? That this is how you figure out the refractive index of glass. Now for the second part, if it is placed in water, you're gonna have to use the same formula, but in place of 1, you're gonna have to plug in 1.33. So again, I'm right using the same formula here, but I'm just gonna plug in the values, right? So n1 is going to be 1.33, right? Sine of angle A is still 60 degree, but this time we don't know del min divided by 2, and this is equals to n2, which is, now this time we know n2 because we figured it out in the first part of the question. So it's 1.53 into sine of 60 by 2. Now again, you'll need a calculator to solve this particular question, because again, you'll have to take sine inverse and stuff like that. But when you solve this question using a calculator, you're gonna get the value of minimum deviation as 10 degrees. Like the minimum deviation angle comes out to be around 10 degrees from this particular equation, right? So this is how you solve the question. I'll see you in the next video.